Alright, in case you're not, make sure you are using audio for this because I'm going to say a lot of these things. So first off, you need to make sure you put this in a nice table. Probably should have time, force 1, force 2, and you're essentially just going to take this whole area and plop it into that table. You also have your F max, 1 and 2. You can find, essentially your max here is actually going to be your min. It's how far down it goes. So for 1, our total distance it's gone is 15.92. For 2, it's gone really similar, but it's 15.56. Then you need the F mean. This is also for 1 and 2. That's written right here. I almost kind of went over it. It's about the same for both. One is 4.2, and the other is 4.25. You could write all the whole numbers out. And then you need the delta t. So the delta t for this is you need to find how long did this interaction actually occur. You can see right here is where it started to go up. Here's its peak, and then here's where it went back down. So, oops, move that. So your starting point is here, your ending point, and remember it's final minus initial. So it'd be 1.54 minus the 1.5. In my case, your numbers will be different. 0, so your total time is 0.04 seconds. And this would be for both of them. So hopefully you have a solid data table. And I'm going to get rid of this picture. Or actually, no, from here, then you would go to graph each one. You'd use your numbers here. So you'd make a graph. 0 is probably going to be somewhere here. You're going to want to space mine. It goes up to about 16, so I'm going to want to space it for 16 numbers. So I'm going to count by 2s here. 4, 6, 8, 10, 12, 14, 16. And then I'm going to space these. It's going to be really, really tiny. And I'm just going to say it started at 0, but I'm going to start right here at 1.48, 1.5, 1.52, 1.54 to get all my numbers. So at 1.4, everything's really, really tiny. It's like not 0, but it's close. So your line's going to start here, and then you're going to look at your next point. It's still at 0, and it's not until 0.152, which is here. It's going to start here, and it's still going to go here, and then 0.152, it's going to jump and go up to here, and then at 0.154, it's going to go back. So this is about what each graph should look like. Each one will be slightly different. For example, the other graph is going to look like this, but it's going to go slightly less than the other one, but still look really similar. And these are going to be 2 different graphs. Alright, now that we have this, I'm going to clear some of this stuff. So next you have to find J and delta P. Hopefully by now you realize, hey, they are the same thing. So for each one, you essentially have to find J, which is equal to the force average, or the mean force, which hopefully you already know, and delta T, which, again, hopefully you already know, per car. So you need 1 and 2. So you find your F mean for 1, which is written right here still, which is 4.212. You know delta T from our previous, which was 0.4. Multiply it. And then for your second one, same idea, 0.254 per right here, times our delta T, which again is still 0.04 seconds. Multiply them, and you're going to get your Delta P. I'm not going to write an answer because you all should have very different answers from me, depending on how hard you hit them together. But that's how you're going to do the calculation. So this is going to work for both the change of momentum and impulse because they are the same thing. Otherwise, you can calculate each of them separately, but it won't change your answer. Alright, hopefully this helped you do it. Make sure you have it ready to show me tomorrow. I'm essentially going to grade it on the spot. Remember, when you're graphing, make it nice and evenly spaced. You can even use your graph that was given to you that you hopefully took a picture of as a good example of it. Alright, hopefully this is helpful, and we're starting the performance test tomorrow.